Hey guys, this is the final video, yay, on matrix algebra. So it's the third one. We're going to talk about solving simultaneous equations. I haven't even spelled that right. Solving simultaneous equations using matrices. So we're going to jump straight into some examples. If you haven't watched the first or second videos, please make sure you watch them first or you won't understand. We're going to talk about inverses and you won't understand that if you haven't watched that second one especially. So the first example we have is find x. So x is a matrix. Find x, we don't know anything about it. Find x if this, we can call it ax equals b. So it's like having just ax equals b, but in matrix form. So we know that we talked about it in the last video. If I have ax equals b, then x is equal to the inverse of a times b. So a is out the front, so it needs to be out the front on the other side. So we have x equals a, which is 1, 2, minus 1, 3, inversed times 4, 2, 1, 3. So first I need to know whether I can actually do this. I need to know whether I can find the determinant of this matrix. If we can find the determinant of this matrix, we can find the inverse. So the determinant is AD take BC, which equals 1 times 3 is 3, take minus 1 times 2 is minus 2, which equals 3 plus 2, which is 5. Tick, okay, we can find the inverse. So that means that x equals, now if you remember our swap and minus, so we're going to swap a and d, 3 and 1, and b and c will stay where they are, but we're going to have the negative of them, minus 2 and 1, and then we divide by 5 all of these, over 5, didn't leave myself enough room, over 5. And so that is the inverse multiplied by 4, 2, 1, 3. And what this gives us is equals, you can do all this working out, 10 over 5, zero over 5, 5 over 5, and 5 over 5. And you multiply the two together, which equals 2, 0, 1, 1. So quite simple, finding x. The hardest thing was finding the inverse. So that's what all this was, is the inverse. Okay, so we had to swap these two here and minus these two here. So find the negative of them. And then we just go through as we normally would multiply. You can go back and watch that again if you need to go through it a bit slower. So this is really what I want to get to. So we have two what we call simultaneous equations because they both have x and y in them. They're of the same form, and I want to solve for x and y. And I can actually do this using matrices because I can write this as a matrix. The way I'm going to write it I'm going to go, I have 2, 3, I'll explain it in a sec, 5, 4 times xy equals 2, 12. So all I've done is written this in the form of a matrix. So if I then multiplied this out, I would be going, 2 by 3 times x by y. So I would be having 2x plus 3y. And then I would have 5, 4 by xy. So 5x, 5 times x plus 4 by y. So I'll quickly just write that in. I would have 2x plus 3y, 5x plus 4y. If I multiplied those two out, and we can see these two are of the same order. They're the same size. Okay, this is a 2 by 1, and this is a 2 by 1. So when we talked about our matrix equality, because it's the same size, these two can be equal. So we need 2x plus 3 to equal 2, which is what we have here. That's one of our equations. So this is just sort of for your own benefit to see that I'm not lying to you. That's not actually part of our calculations. So I'll write this fresh now that I've drawn all over it. 2, 3, 5, and 4 times x, y equals 2, 12. Now I want to solve for x and y. So I want to get this matrix here on its own. So to do that, like we did before, we need to take this matrix to the other side. To do that, we go x, y equals, keeps freezing, 2, 3, 5, 4 inversed times by 2 and 12. So I need to always make sure, because this here is out the front the first time in this original equation, it's going to be out the front on the other side as well. So like we did before, we know that to find the inverse, we first need to find the determinant of A. So let's call this A. So that's AD take BC, which equals 2 times 4 is 8, take 3 times 5 is 15. So 8 minus 15, we have minus 7. So tick. It can be negative, the determinant, it just cannot be 0. Otherwise, it can be any other number. So now to find x and y, I need to have the inverse. So I'm going to do my swap. So 4, 2, and my minus. That's what that one is. So minus 3 and minus 5. So the ones that get a negative, they do not swap places. Only those first two, 2 and 12. And now, because we don't have this sticky minus 1 up here, we just multiply out. And we get 4 times 2 is, oh hang on, no, I haven't finished this, have I? Nope, my bad. Over minus 7, over minus 7 over minus 7. Be careful, I always forget that bit. So now let's write this a bit better. So I swap minus minus and divide by the determinant. So I have 4 over minus 7. Then I have minus 3 over minus 7. So I can just call that 3 over 7. Those negatives cancel out. Then I have here minus 5 over minus 7. Again, these can just cancel out, makes it a bit easier, a bit prettier. And I have 2 over minus 7. Rewind that if that's confused you. That was my bad, I forgot. Okay, so when I multiply this out, I'm going to get, I have to multiply these plus this. So I get 28 over 7. And when I do my next row, this times this, it's getting a bit ugly. I have 14 over minus 7. So that tells me that's equal to 4 and minus 2. So then, because I have xy, and we know because of our matrix equality, if xy equals 4 minus 2, x equals 4, y equals minus 2. So that's a bit of an example and an introduction into solving simultaneous equations using matrices. I'm sure you'll have some questions because that was a bit rough, but I think that you guys will understand that, and then we can talk more about that in class and do some more examples, and you've got plenty of questions to practice. So that's the end of our matrix algebra videos, and I will see you in class.